Now we will discuss what is clustering and its application. See, first of all, let us know what is clustering is. See, clustering is nothing but grouping of similar objects together. We can call it as a cluster. See, let us suppose say when we get when data set is given, it is having different number of objects into it. So what we can do? So we'll be finding out different similarity between each and every object within the data set, so that similar objects will be grouping the similar objects, so that will from one cluster. Likewise, all the similar objects will form a single group. We can call it as a cluster. And as we know, in data mining we'll be having supervised learning and unsupervised learning, right? See, this clustering comes under unsupervised learning technique. See, the real-time examples of clustering are, this clustering can be used in market research analysis, pattern recognition, and image processing as well. See, let us suppose say, consider one example where uh, you are grouping of customers in the market. How you will do? See, let us assume that we as a customer will be purchase some groceries from the grocery shop, as well as we as a customer purchase clothes from the cloth merchants, as well as we as a customer and will purchase all gold ornaments from the shopping mall, right? See, here also customers are divided into different categories, one in merchant, one in like cloth merchants, one in like gold shops, and one in like daily grocery shop, right? See here, clustering in market basically it will be used for differentiate between the customers. Will be using the clusters over there. Similarly, see, in internet, if you search for a particular document, so let us suppose you are searching for the document regarding information security. It will give us document regarding that particular subject only. And if you are searching for the document regarding data mining, so it is giving that particular PDF or word whatever we type over there, right? Here also clustering is also helping in the internet allocating the documents to for a particular data discovery concern. See, these are the real-time examples where clustering will use. Generally, this clustering can be used in four methods. One is hierarchical clustering, partitioning clustering, grid-based clustering, as well as density-based method. So these are the four methods usually we use. In this video, we are trying to learn what is hierarchical method is. See, hierarchical clustering. See, as I said you, it is a basically clustering is a unsupervised learning. Here, when you consider hierarchical clustering, no, see, it will consider each and every data point in a data set as a single cluster. See, again, this hierarchical clustering can be divided into two categories. First thing is agglomerative hierarchical clustering, and the next thing is divisive clustering. See, let us see each and everything in detail. See, agglomerative hierarchical clustering. See, this is a bottom-up approach. See, agglomerative, the meaning in sense, which means that, see, each and every data element individually we'll consider as a single cluster. Later on, we keep on merging two objects together to form a double cluster. Later on, in later steps, we keep on merging three objects to form a cluster. Let us see how this will work. See, I have a data elements. Consider A, B, C, D, E, F. So these are the data elements I have. So I initially what I'm considering, so each and every element I'm considering it as a single cluster. So based on this, in the later step, I'm assuming that BC together, BC are having similar properties, so that I'm making that particular group, so that BC forms a cluster. Similarly, I'm assuming that in the second case, DE forms a DE are having like similar properties. So I formed one more group, so that I'll be forming one more cluster here. So this is what two object clustering. Later on we'll be forming three object clustering. Here I'm merging two object clustering of DE along with the single object called F, so that I'll form DEF, which is a three object clustering. Later on, based on the requirement or based on the analysis of our data, we will form four object clustering or five object clustering till all the elements in our data uh, in our data set are formed together. So here I'm considering it as BCDEF forms a single cluster, so that I grouped it. Later in the last step, all the data elements A, B, C, D, E, F together forms a single cluster. That means that what we have done in agglomerative clustering, see, in the step one, we have considered each and every point, each and every data element as a single cluster. In the later step, we'll be combining two objects and form a single group, and we'll call that as a cluster. In the later on steps, we'll be forming three object clustering, later on four object clustering, till all objects together we have to form a single cluster. This is what agglomerative hierarchical clustering. See, let us see. This is the data elements. If the numerical, generally in data set, we'll be having attributes along with the some numerical data, right? See, if the numerical data is given to us, how it will work? Let us see that also. So initially, this is what an example is. See, we need to find out, we need to perform agglomerative clustering on these points. See, they have given us point 1, 2, 3, 4, 5, 6 on basis on x-axis and y-axis. These are the coordinates for each and every points. So what we have to do, we need to find out all the clusters. Here the data points are P1, P2, P3, P4, P5 and P6. We need to apply so agglomerative clustering on these data items. How it will do? See, what we have to do initially, we need to calculate distance between each and every cluster, each and every data point in a given data set. See, here if you observe carefully, we have P1, P2, P3, P4, P5 and P6. These are the data points they have given. So initially what we have to do, we need to calculate the distance we need to calculate the distance between the 2 points. That will be calculated using Euclidean distance strategy, which is square root of x2 minus x1 whole square plus y2 minus y1 whole square. This is the formula which is well known to calculate distance using Euclidean distance method. So I'm considering P1 and P2. So P1 is x1, y1, P2 is x2, y2. You're just calculating the distance between the P1 and P2 using Euclidean distance formula, which is x2 minus x1 whole square plus y2 minus y1 whole square, so that we will get the result. Similarly, so how many points we have? P1, P2, P3, P4, P5 and P6. Totally we have 6 points. We need to calculate distance between all the points. P3 P1, P3 P2, P4 P1, P4 P2, P4 P3. Likewise, we need to calculate each and every point Euclidean distance formula, so that you will get these type of matrix. See, while calculating distance between the 2 points, either you can calculate a points of either upper triangle or lower triangle. See, because both the values are similar, right? If you consider P1 P2 and P2 P1, both the values are similar, right? Ultimately you are calculating the distance, right? So either you can calculate upper triangular matrix or lower triangular matrix. That is enough. Now After calculating the distance, what we have to do? So you need to construct distance matrix. So in this distance matrix, on x-axis and y-axis, you need to maintain all 6 points, and all the diagonal elements you need to keep it as a 0. Later on, we have calculated the distances, right? You just substitute it either in lower triangular matrix or in upper triangular matrix. You just substitute the distance between these points answer over the cell. Then what we have to do later on, you need to find the minimum distance over all the answers we found it. See, the minimum distance here is 0.11 under P6 with P3. That means that the first cluster initially we have considered P1, P2, P3, P4, P5, P6 as an initial cluster. Now we are merging P3 with P6 so that we will be forming two data point cluster. Why we are merging P3 with P6? After finding the answers for Euclidean distance between these 2 points, this we got very less value, so that we can consider this as a single cluster. P3, P6 together will form a single cluster. Now you can eliminate this column as well as this row, so that this will become like this. So P3, P6 will be eliminated, and thus P6 will be merged with P3. Now P3, P6 will be merged with a single row and column. Now, whatever the matrix we got as a result, again you need to calculate the minimum of it. Now 0.14 under P2 with P5 we got it, right? Again you need to merge P2 with P5 as a single cluster. Hence, we will form like this. P2, P5. Again, this is the matrix we got it. Again, you need to calculate the minimum of it. Either you can take this one or you can take this one. Now, observe carefully. This is the resultant matrix now. So here, we got 0.15, 0.15 two times. Now, if you take this point, we can have 4 data elements into a single cluster. That is P2, P5, P3, P6 as a single cluster. Otherwise, if you consider this particular point, this is also minimum, right? It is also 0.15. So if you consider this particular point, what it will be? P3, P6 and P4. You will be considering only 3 points. But if you take this one, we'll consider 4 data objects into a single cluster, so that efficiency and the complexity of an algorithm will also reduce, right? So you need to think in that way also, so that you need to reduce the time and the efficiency of an algorithm. Now, so here we are considering this so that P3, P6, P2, P5 forms a single cluster. Thus, will become the matrix becomes like this. Again, this is the this is the minimal point 0.15 under P4, P2, P5, P3, P6. So again, you need to merging of these 5 data points in a single cluster, so that the resulting matrix would be like this. And after all this, 0.24 is the minimum value which we got in this matrix, so that P2, P5, P3, P6, P4, after all P1, this is the cluster we formed. Later on, this is the process we followed for agglomerative hierarchical clustering. See how we have done. Initially we have taken each and every data point as a single cluster. Later on, we merging up 3 with 6, 1 data point, 2 with 5, 1 data point. These 2 points together we form one single cluster. Later on, these 4 points together with point number 4 will form single cluster with 5 data elements, and these 5 data elements along with the point 1 will get all the data elements together with a P3, P6, P2, P5 and P4 and P1. This is the sequence we form as a cluster. So this is the technique which you need to follow for agglomerative hierarchical clustering. If you draw this particular diagram, this you can call it as a dendrogram. See, this agglomerative hierarchical clustering, you can also represent it with AGNGS, Agnes, AGNGS. So this is what agglomerative clustering is. And the next hierarchical clustering is divisive. See, it is simply opposite of the previous one. See, agglomerative is bottom-up approach where we have considered each and every data point as a single cluster. But in divisive, we'll consider all the data points together as a single cluster. Later on, we'll divide it into the clusters. See, let us see how it will do. So, initially, all the data points are P, Q, R, S, T, V. All the data points together, we form a single cluster. From this, we have divided into two clusters. Those are, one point is P and the other point is Q, R, S, T, V. From here, we have 5 data points. We have divided it into 2 and 3. 2 points are QR and the other 3 elements are STV. Again, from this STV cluster, we have divided into ST and V, and from here S and T. And later on, if you come across QR here, it is again divided into, one point is Q and the other object is R. See, what it is done in divisive, it is a top-down approach where we have considered all the data objects into a single cluster, and we are dividing into a group of elements where till we get as a single data element as a single cluster. So as it is a top-down approach, the steps are like this. In the initial step, we are considering all the data elements as a single cluster, and later on we are dividing it into a group of objects till we got a single cluster. This is nothing but the divisive hierarchical clustering. This is a very important clustering and easy clustering technique in data mining.